Well, we'd start this problem by plotting points A, B, and C. Next, D is the midpoint of AC. So this is our next step. To use the midpoint formula, just show the coordinates of D. So it's the midpoint of segment AC, so we'll use C's x-coordinates and A's x-coordinates, negative 2A and 2A. And we'll use C and A's y-coordinates, which is 0 and 0. Negative 2A plus 2A is 0, so D's coordinates are 0 over 2, which is 0, and 0 over 2, which is 0. So D is the origin. All right, now we need to find E's coordinates using the midpoint formula, and it's the midpoint of segment AB. All right, so again, E is the midpoint of segment AB, and so using the midpoint formula, we'll take A and B's x-coordinates, which are 0 and 2A, and after the comma are the y-coordinates, so the average of the y-coordinates of A and B, which are 2B and 0, and 0 plus 2A is 2A, 2A divided by 2 is just A. And here we also have 2B divided by 2, which is just B. All right, now what? All right, so D is the point 0, 0, and E is the point AB, and we know this because of the midpoint formula. So after the given stuff, this is where we'd go next. Then what? Well, we're trying to show that triangle AED is isosceles. Triangle AED is this one, right there. So how will we show that that's isosceles? We'll show that segment DE is congruent to segment AE. And how are we going to do that? Well, we show that segments are congruent by showing that their lengths are the same. And the length of this segment is the distance from D to E. And the length of this segment is the distance from E to A. So we will use the distance formula. All right, so in our workspace, let's use the distance formula to find the length of this left side, DE. We're going to subtract the x's, and we'll subtract the y's. So what are D and E's x-coordinates? 0 and A. What about D and E's y-coordinates? 0 and B. 0 minus A is negative A. Negative A squared is negative A times negative A, which is a positive A squared. And then 0 minus B is a negative B, and a negative B squared is positive B squared. All right, now let's find the length of segment AE. A and E, here's A's coordinates, and E's coordinates are right here. So we'll subtract the x-coordinates first for points A and E, which is 2A and 1A. And then we'll subtract point A and point E's y-coordinates, which is 0 and B. All right, and 2A minus A is 1A. A squared is A squared. 0 minus B is negative B, and when you square that, we get positive B squared. And what have we shown here? The length of DE is the square root of A squared plus B squared, and so is the length of AE. So we just showed that the lengths of these two sides here are congruent. We'll want to say that in our proof. DE is equal to AE. You don't have to, but you could say that they're both equal to the square root of A squared plus B squared. But we've got our work in the workspace, which makes it really clear. All right, so they're equal to each other by the distance formula. And if they're equal to each other, then they're congruent. But that's good enough. We can say at this point our triangles have to be isosceles. These sides are congruent by the definition of congruence, but I'm not picky. If you say their lengths are equal or the segments are congruent, it doesn't matter. it's clear that in both cases we've proved that this triangle has two congruent sides, or two equal sides. So that is isosceles, which is what they asked us to prove. And we finish this off by saying, well, that's what it means. If we showed that two sides are congruent, that's what it means. That's the definition of isosceles triangle. And that takes care of problem number 18, this optional problem that some people chose to do for extra practice.